What's up, math scholars and math haters? This is Mr. W. We're going to continue with our probability unit in discrete math by taking the basic idea of probability that we started talking about in my last video, the idea that the probability of a particular thing happening is just the number of ways that that particular thing can happen, that event can happen, divided by the number of total possible outcomes, the number of total possible things that can happen if everything is random and equally likely to come up. We're going to take that idea and extend it to the fundamental counting principle, which, if you remember, is the idea that if you have a big thing or a big idea, like, for instance, a fancy dinner, and you have choices for different parts of that, like you have choices for an entree, meat entree and veggie entree, and then 3 options for a side, fries, okra, and corn. The fundamental counting principle is the idea that the total possibilities for that whole thing, the meal, can be found by multiplying the options for each part of it, for the entree and for the side. So we're actually going to start with this as an example because I've gone ahead and start over from right after I finish explaining the scope of the objective. So we're going to take the fundamental counting principle and do a little bit of probability with it. I started with this example of a fancy dinner because it was the first example that we did in my fundamental counting principle video. So essentially, as you can see, we have a meat option and a veggie option for the entree, and then fries, okra, and corn for the sides, and we're trying to figure out first how many possible meals there are. The fact that probability is always something divided by the number of total possible outcomes means that it's going to be really good whenever we see a problem like this to start by just asking ourselves how many total possible meals or outfits in the next example or area codes in the third example or whatever there are. All right, so in terms of how many possible meals there are, we have entrees and we have sides. We have 2 options for an entree, 3 options for a side, which gives us 6 possible meals. And this number is going to come up a lot as we keep going with this problem. So let's go ahead and see what the probability of choosing a meal with meat as the entree is. Now we're going to actually, for each of these questions that just asks for a particular probability, since we're trying to find the number of ways that that particular thing can happen, we're just going to go ahead and look back at the example, the framework that the problem gave us in the first place. And we're going to take that information and we're going to use the fundamental counting principle with the restrictions that a particular question is giving us. So for instance, if we're looking for the probability of choosing a meal with meat as the entree, normally, if I'm looking for the total possible meals, I have 2 options for an entree. But since now I'm only interested in meat, that means that I have 1 choice for an entree and then 1, 2, 3 choices for a side if I want to get a meal with meat as the entree. So that means I have 1 choice for an entree, 3 choices for a side. That's 3 ways to get what I want out of 6 total possibilities. And 3 out of 6 you might know is 1/2 or 0.5. So next we're trying to get a meal with okra as the side if we're picking randomly. Again, coming back up here, there are no restrictions on the entree, so there's still 2 possibilities there, but now I'm only interested in okra as my side, which means I have 2 possibilities for the entree and just 1 possibility for the side, which means that if I come down to answer this, 2 entrees, just 1 side. That's a 2 out of 6 probability, which your brain might automatically simplify down to 1/3, or 0.3 repeating. And finally, veggies and fries. So we want a meal with our entree, or where our entree is the veggie option, so that's just 1 option for the entree, and then we're only interested in fries for the side. So that's just 1 option for the side as well. So, using the same idea, there's 1 choice for the entree and 1 choice for the side. That's 1 possibility out of 6 total. And again, the fact that 6 is the denominator in each of these fractions is just from the fact that there's 6 total possible meals to begin with. But anyway, 1/6 you might know as 0.1 and then 6 repeating after that 1. So that's the first example of using the fundamental counting principle and probability at the same time. Now we will get to the second example. this example is also kind of a callback to the video I did on just the fundamental counting principle when we did a little problem about outfits. So we have, and I've actually laid out the choices here because this does get a little trickier if, for instance, we have 2 white shirts and 2 red shirts and 1 green shirt out of 5 shirts, so it's not like everything is different. And then we have 2 khakis out of 4 pants and that kind of, and so on. So we're supposed to find the probability of picking an outfit with, for instance, first we have a white shirt. Now, you'll notice I did not put a question here that asked what the total number of possible outfits was, but I do want to go ahead and figure that out. Essentially, 5 shirts, 4 pants, and 3 shoes. To get the total possible outfits from that, we're going to multiply 5 times 4 times 3, which gives us 60 total possible outfits. And just like the other example where we had 6 total possible meals, this number 60 is going to end up being the denominator in each of our probability fractions. So let's go ahead and figure out the probability of picking an outfit with a white shirt. Now for this first problem with the white shirt, once again, we're just looking to see what the particular question is restricting us on. So in the case of the white shirt, instead of 5 options for a shirt, now we have 2. There are no restrictions on pants or shoes, so we still have 4 pairs of pants that we can have and 3 pairs of shoes that we can have. This is going to give us 2 times 4 times 3 is 24. We're still dividing that by 60, and 24 divided by 60 is going to give us an answer of 0.4. So next, we're trying to find the probability of picking an outfit with khakis. Now this is a restriction on pants, which means that we can still pick any of the 5 shirts and any of the 3 shoes. So that means that we'll have 5 times something times 3. So we can still have any shirt and any pair of shoes. But now, there's 2 pairs of khakis that we can choose from. So if we're looking for the probability of picking an outfit with khakis, instead of 5 times 4 times 3, now I have 5 times 2 times 3. Because I restricted the pants that I could choose from in the particular event that I'm looking for to just the 2 pairs of khakis. So 5 times 2 times 3 gives me 30. Divide that by 60 and you will get 1/2 or 0.5. Now, let's look for the probability of picking an outfit with flip-flops. Going back to my choices for shirts, pants, and shoes, I can pick any shirt, I can pick any pair of pants, but there is only 1 pair of shoes that I can choose from now. So I'll be multiplying 5, because I can pick any shirt, times 4, because I can pick any pair of pants, times 1 for the pair of flip-flops. And if you were picking an outfit for work, I would not recommend picking flip-flops, even randomly. So this is 5 times 4 times 1. That gives us 20. Divide that by 60. It will give us 1/3 or 0.3 repeating. So now we come over to the examples that are kind of like in the fancy dinner example when we had to find the probability of picking a particular entree and a particular side. Once again, we're just going to look at the event that we're looking for, see what it restricts us to in our choices for the different parts of the outfit, and find that probability. So if we're looking for the probability of picking an outfit with a green shirt and jeans, coming up to shirts, that's just 1 choice for a shirt now, so I'm going to do 1 times something. Coming to pants, there was just 1 pair of jeans, so that's 1 shirt times 1 pair of pants. And there were no restrictions on shoes, so that's just 3 shoes. Which brings me to 1 for the 1 green shirt I could pick, times 1 for the 1 pair of jeans I could pick, times 3 for the 3 pairs of shoes I could pick. 1 times 1 times 3 gives me 3 out of 60. That's going to be 0.05 or 5%. Next example, picking slacks and picking dress shoes. There were no restrictions on shirts, so when I start the things that I'm multiplying, I have 5 choices for a shirt. I come to my pants, and there's only 1 pair of slacks, which means that I'm going to have to multiply 5 times 1. And then I'm looking for dress shoes underneath my shoes, and there's just 1 pair of those. So that's 5 times 1 times 1, which is 5 out of 60, which is 0.08, and then 3 repeating. Finally, the last example, we have a restriction on each part of the outfit. We're supposed to find the probability of picking an outfit randomly with a red shirt, with khakis, and with dress shoes. So let's start with the red shirt, and if there are any fans of the original Star Trek series, you might be feeling like you're about to die right now, but we're almost done with this example. So red shirt, I had two red shirts underneath, or within my range of choices for a shirt. So that's 2 choices for a red shirt. I'm looking for khakis, and I had 2 pairs of khakis. And then dress shoes, I had 1 pair of dress shoes. So that's 2 times 2 times 1 for the 2 red shirts I could pick, the 2 pairs of khakis I could pick, and the 1 pair of dress shoes. 2 times 2 times 1 is 4 out of 60. And I will actually need my calculator for this one. 4 divided by 60 will give a decimal value of 0.0 and then 6 repeating. The third example, dealing with area codes, you'll be able to find that in the part 2 video that I'll have made for this concept.